A couple of days ago, I said I, I did put up uh, an intro video to slope staking, and we just kind of scurried through that. I'm sure you didn't get a lot out of it, perhaps a little bit to get you started. But I said I would come back later in the week with another video, and we're going to take a little bit more of an in-depth dive, and that may yet still need another class or big blue button synchronous class, whatever it takes. But I want to put up this video and we'll cover most of the all of the instructional material. We'll take a look at the week 4 assignment, give you an idea what I'm looking for there, and then there's a couple of quizzes that are multiple choice, and they'll all be based on what we're going to cover in the week 4 here. So we've already went through this video a couple of days ago, and if you want to, go right back through it again. The Let's see, in week 4, which is called slope staking, the overview. Let's see if we got some objectives in here. Week 3, the module, we learned to calculate slope. You remember the for the ratio is horizontal divided by the vertical, and percent grade is vertical divided by horizontal. So we went through those things, and we're going to go through some more. But when we get through with this module, we want to be able to demonstrate the process of staking a field slope. And demonstrate means that we're going to build one. Uh, those of you that this in-person 3-day training session is coming up in what is it, first few days of March, be I think the second, third, and fourth in March is when this will be coming around, where those of you in Oklahoma City will go to Oklahoma City, uh, that are assigned to Oklahoma City. Those of you assigned to the Georgia campus will go there for the same kind of training. I have an announcement up both in Introduction to Excavating and Introduction to Grades, talking about that. And so if you're having problems uh, making those dates that I've assigned, which I believe is the 2nd, 3rd, and 4th of March, 2nd, 3rd, and 4th for the in-person, for both Intro to Grading and Intro to Excavating. Okay, so be able to make adjustments to have all vertical dimensions after the first stake to be 4 feet vertical. That's a matter of convenience, and we talked about that a little bit, but we're going to get into that. And we're going to show how one person can lay out a field slope, stake out a field slope. And I think coordinating with the equipment operators, assisting with rough and finish grading, I think we talked about that in week 3. I'm not for sure, that may have got drug over here somehow. But anyway, if it comes up in here, we'll address that. But I really don't think it's part of what we're doing here. But we'll get into it if we need to. So let's see if we can get back to the instructional resources, which are, lo and behold, they're right here. So in week 4, again, feel free to see that, go back through that quick run through right there. We just looked at the overview, and here are our instructional resources. There'll be slope staking, and then the actual building of a field slope, and then you guys know how to do the tailgates. There's nothing out of the ordinary there, but I will want to take a look at this assignment in this video. I think I'll get to that during this video, because so you can understand what I'm looking for. So let's just get this deal going here, starting out with just slope staking. So I'm going to do a little reading here. Slope stakes, and that right there is an abbreviation for them, are set where the planned slope will intersect with the original ground. This is a slope. This going up, it intersects with the ground here. So if all this dirt here will have to be taken out. This looks like uh, level, and then it goes down again and connects with the ground at the toe, and this is the top. In between, on this rough ground, we'll be setting probably a stake here. This line will not be here until we put dirt here or take this dirt out. So the slope stakes in between are called slope stakes. So offset stakes, we just had a glimpse of that using double line and stuff. So offset stakes are used to prevent the loss of reference information by transferring the required information from the stake located in the immediate area of construction to a new stake set far enough away so that it will not be damaged or destroyed by equipment working in the construction area. A reference point to slope stake is an offset stake as used on slope. It is a reference to the slope stake by horizontal and vertical dimensions. Now, private enterprise sometimes use OS instead of reference point instead of RPSS, while government services might be using that. It will change West Coast, East Coast. It'll be a little different, but it all gets the same thing. Now, offset stakes are used to prevent loss of this is all reference information. If we come by here and knock this stake off, we have the reference point stake, which has got information on it, back here out of the way. That's why it's called an offset stake. This here is a reference point to slope stake, but it is also an offset stake. Now, you may recall when reading these stakes in slopes that we have double line stakes and we have, you won't recall single line, but we'll be getting to those. This is a double line, and as you might recall, I said that literally means and then. So let's look at our directions. And this is the actual slope, starts right here at that hub, and it's a 2-to-1 slope. So let's see what it says. In 10.0 feet level. So go straight out here, level 10 feet, and then I want you to cut 10 feet at 2-to-1. So if we go down 10 feet at a 2-to-1 ratio, how far is that going to put us out here? From here to here. That'll be, go back to that circle, that'll be your vertical times your slope ratio. 10 foot times the slope ratio. So we'll be, keep in mind, just for measurement, we're building stairs. We go down 10, we don't actually cut that dirt right there, but we know to measure out 20, and that's where our toe will be when we get through moving all this dirt around. So again, this is telling us how to build this slope. It's telling you where to start. You need to start 10 foot out here in 10 foot, and you want level with this hub. You put a hub in and then cut 10 feet at 2-to-1. 10 times the ratio of 2 would put us right out here, 20 feet. Okay. The top slope stake indicates the point at which the top of the planned slope intersects with the existing ground or a desired elevation. Intersects with the existing ground or another slope, or a desired elevation has been reached for some other feature, such as a pad for a house. The tack in the hub is set for the correct line and elevation. Line is like this. These stakes all need to be lined up, whether they're going downhill, uphill, or level. And elevation. This is elevation. Okay. Getting a little bit, this is a top stake. This is a toe stake, and the toe is the bottom of the slope. So this is going to be what kind of a slope? Is it going to be a cut slope or a fill slope? It's going to be a fill because we're starting at the toe. This slope is not built yet. The way you build this is you bring in dirt and lay it out in lifts like this, and then you'll have a little stairway built, and then you'll cut the stairs off and you'll have a slope left. So we'll get into that before the module is out. So let's look at this toe stake. This is where the slope is going to start, and it says fill 8.3 at 2 to 1. So we're going to go up 8 feet, we're going up 8.3 feet at 2 to 1. I'm not going to go through that just yet. I'm just telling you, this is what a toe stake would look like at a fill slope. So here are some slope stakes, more slope stakes. This is a toe stake. This stake is in the building of the slope. Slope stakes are generally marked with a cut or fill mark. Right here, this has a fill. Fill 9 foot at 2 to 1. The slope, it'll have the slope ratio and sometimes the distance from a center line of a street or highway. Fill slope stakes should also have, they're called a high cup, that's that boot, at 1 foot above grade. I don't know if you recall from last week, but we're always gonna shoot to have a 4 foot vertical, as you recall, but we want to shoot 5 foot, and that's going to be a 1 foot boot. The actual grade will be down here, which will be 4 foot. The reason we do that is that overspill may cover up this grade reference point here, and so this boot would tell us that we're down 1 foot to where grade is. So we may have to dig it out with a shovel so we could find it. Okay. This, again, we're looking at a profile, and remember the slopes are like the little wedge of cheese. You know, they continuously go. They go up the slope this way, but they do it a bunch of times. So you're going to have a whole bunch of toe stakes going in these directions here. Remember the axes I talked about. You got to visualize this as 3D. This is a profile. This is under the ground here. This is an aerial view of these stakes right here, all lined up, and a plan view. So this is simply saying, here's your offset stake, which will tell you where to put this, and then on your toast, then it also tell you what kind of slope you're going to have. And these are just views. This is a profile view. This is a plan view. Plan views are looking down. Profile views are if you were sitting at the kitchen table, and this is what your kitchen table looked like. Okay. Only way that you are going to put the toe and all subsequent slope stakes in a correct line is to start in exactly the correct direction from the offset. That's a line only lath they're talking about. Surveyor will set this line only, and he will set this reference or offset or reference point to slope set. And this will give you the ability to use your hand level and line these stakes up so that they're straight in line as this overhead view shows us. They need to be straight in line. And they're going, when I go down, I'm coming at you, trying to get you to view this as a three-dimensional object. Of course, this is just looking from above. Let's see. Substance is the exactly correct direction from the offset. We're just talking about the line. Figure 64 is talking about, they've got 1.5 to 1 slope, but it says shows the location of the different types of stakes used in a typical slope. This is where it all begins. This is where the information is. There may be a line only stake out here, so you can line this toe and then from there go on up. This is your offset. This tells you where on this stake will tell you where to set this stake, and then this stake may have written on it telling you where to set these stakes. And as you may recall, we're shooting for an elevation of 4 feet. And if you don't have a multiple of 4 as a total fill, you're going to have to do the little highest multiple of 4 that can be subtracted from whatever the total fill is. And we'll be able to go through that in further into this module. Okay. You cannot assume that the hub elevation at any offset is the same as the hub elevation for the toe. This is what he's talking about before we go. In this case, the hub elevation for the offset is level as the hub elevation for the toe or the top in this case. That's what he's talking about. So what we have to do in this case, obviously, here is your hub for the offset or the reference point to slope stake. Here is your hub for your toe stake, your starting point. This is telling you everything you need to do to build this 2 to 1 slope. The first thing it's saying is I'm an offset and I happen to be offset 10 feet from where you need to start. That's the way that reads. So at 10 feet, I want you to cut 1.1. What it's telling you is this, go out here 10 feet and go down 1.1 foot, and that's where you set your hub. Once again, I'm offset 10 feet. So I want you to, in 10 feet, I want you to cut 1.1. So that means I'm up here. I need you to start 1 1/10 lower than my hub, this surveyor's hub. So it's going to say cut 1.1, 10 feet out here. So we'd have to come out here and move dirt probably before we even got the first stake in the ground. And set, so we could set that hub 1.1 below that right there. Okay. Let's move on. Well, we'll read this. So, and then I want you to fill 11 feet at 2 to 1. So you would put the toe stake here and you would put this information on the toe stake that was on here in this case. And then after you move, set your hub, and then I want you to fill 11 feet at 2 to 1 right here. And then fill 11 feet at 2 to 1. So you'd go ahead and put it on this stake, and then you would set your first stake above toe up here after you brought in a bunch of dirt. They just keep laying it down, going east and west or to and fro here, and you keep you'll have stair steps, they call them lifts, going up, and you'll come eventually and cut those stair steps out. So let's not get too far ahead here. Offset, and then telling you where to set your toe stake, and then what to put on your toe stake, and actually what to do. So do we need to go next? building a field slope. Yes, we do. So far in this book, we have dealt with the basic tools, horizontal and vertical measurement, and other fundamentals. Let's not skip an important now. How to drive a lath. Any lath, this is worth reading too, by the way. Any lath worth putting in should be driven well into firm material so as not to fall over at the first earth movement or good wind. It should be placed with the flat side facing the equipment operator. After all, the information on the lath is for the equipment operator, and if you do not place it properly and make your markings legible, the operator cannot be expected to grade properly. On field slopes, the flat side of the lath is sideways to the slope because the dozer is going to be running away and toward us up across this slope. You don't build it pushing dirt up. Well, you're doing some kind, but you have your dirt all piled up and then you start cutting it down to the grade you want it. Let's see, if you do not place it facing a slope, you will be looking at the narrow edge. You'll be standing out here and looking at the narrow edge instead of the flat edge. We show it like this so we can show the writing on it as we're describing this situation. Like here, all of this information would be facing uh, the slope, and then these stakes would be facing the way they are. This one again would be, because that's you need to read this stuff to set this toe. A lath driven out of plumb, let's see, legible, we talked about driving it in right. So a lath driven out of plumb not only looks unprofessional, but cannot be used for line at a later time. In other words, if this stake's leaning one way or the other, you can't line up on it, nor can you use any elevation markings, because if this stake tilts over, your elevation is going to be off. Especially if you're using a crow's foot instead of a hub, it's going to be off a little bit. So it needs to be plumb. Since slope stake, for those that don't know what plumb means, that means straight up and down. Since slope stakes are set where the planned slope will intersect with the original ground, right there, you need to locate the offset and line only stakes first. Using the line and information provided on them, you establish the toe stake. Figure 66. So we're getting out here, we're going to line up and we're going to use this information. Look at here, 10-foot offset and then level. That means this is level with this. So whatever elevation this is the same elevation because it's 10 foot, but it's 10 foot level. And then it says fill 8 at 2 to 1. Now this is a good time to kind of throw in, I keep talking about this multiple of 4 thing. We want a vertical dimension from here up and over to the next hub at this stake, 4 feet. Now, in this case, 8 is a multiple of 4, so that's a no-brainer. We don't have to make the rest of them 4. They're all going to be 4 foot if we put the first one at 4, because it's a 2 to 1 ratio, and it's a total fill of 8 foot. And so there's going to be 1, 2 stakes till you get to the top. This is going to be 4, and then the next one's going to be 4, and there you are. You're at the top, 8 foot. We'll talk more about that. Here's your little get me out of trouble circle that I have tattooed within my brain. After the original ground has been prepared and the building of the slope begins, it'll be necessary to replace any lost toe of slope stakes. Keep in mind that you must also reestablish elevation, normally on a hub, along with location line. In other words, look here, if we were at the top or the bottom and I knocked this toe stake over, I would still have this to reestablish this elevation. Does that make sense? Uh, that's why they're offset. If I accidentally knock this off, or on purpose get it out of the way so we can run the motor grader down through there. Get it out of the way, I can reset it using the information here and this hub. I can reset that. So keep in mind that you must also reestablish elevation normally on a hub along with location line if any of them get lost, knocked over. For this example, we will describe a 2-to-1 slope because it is one of the easiest to understand. And it's got the number 1. These are 3, 4. Cool. I wonder if I ever noticed they were numbered. Anyway, this is when we actually start laying this guy out. I've talked about that. When the field is about 5 feet high. All right, let's go up here. After the original ground has been prepared and the building of the slope begins, we're right here. Everything else has been done, and we're starting to bring this dirt in, going in this direction, laying it out, and lifts like before any of this dirt is put in here. Here's the original ground. Before any dirt is put in here, this is what it looks like. And the first thing we'll do is come through here and probably just level that out. And then maybe we'll come up a foot and lay a foot of dirt up here. And then we'll move over and put another foot of dirt down and over and another foot. So we'll start laying those lifts down. Remember, and they'll look like stairs is what they'll look like. So the first lift will go all the way over to wherever this slope stops. So after the original, you must reestablish. Okay, we did that. For example, 2-to-1, we're going to, when the field is about 5 feet, in other words, when we get this dirt up here about 5 feet, and it will continue on this way because we're going to bring more in like this. When it gets up to about 5 feet, hold on, I lost it. When the field is about 5 feet high above the hub located here at the toe, you should set the first lath to find out whether the field slope is overfill or underfill. In order to do this, measure a horizontal distance of 8 feet plus above the toe. And I'm talking about not 8 foot this way. Did I say 8? 8 feet in this direction, horizontal. Where'd the 8 go? You should set it first left, fill, overfill. Okay, in order to do this, measure a horizontal distance. A horizontal distance above, it says above, but it means put your tape measure here and go 8 foot this way. About 8 foot, and go a little further. So it looks like it says 8 foot plus above the toe stake, and drive the first slope stake in. Remember that slope, horizontal slope, is going to be that first stake's going to be 8 foot away, because not because of this 8 foot, because it's a 2-to-1 slope and we want a 4 foot elevation. So we would take the 4 foot elevation, that's the vertical, and then we'd multiply it times 2 to get the horizontal 8 foot. So we're going to put a tape measure here, and we got dirt going up, 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 and we're going to walk up here, pull that tape across here, and go a little further than 8 foot and drive a stake in the ground. That's where the 8 plus comes from. Measure 8 foot plus above the toe stake, first stake. To get an exact measurement though, hook the tape to the back of the lath and pull out just past the toe hub. Hold the plumb bob over the center of the hub. If your measurement is over or under 8 foot, relocate the first slope. You can't move this hub. So do you know what a plumb bob is? It's that thing, that weight on the end of a string that tells you when you're right above this and you got your tape measure pulled out this far and you drop your hub, and right there where your string is on your plumb bob, or this top of the stake is, let's say, after you just put this in the ground approximately a little over 8 foot, but it reads 9 foot. So if I wanted to read 8 foot, I don't do anything. I go measure this, go back to here, hook on to this temporary deal we put in the ground, mainly just to hook on with the tape. Pull it back again. It reads 9 foot. So I hold the tape as I'm walking up here and I pull on it until it reads 8 feet, and I put another stake in the ground right there, right at 8 feet, and then I get rid of this holder. Instead of another person holding your stake, all you did was stand a stake up there and drive it to the ground so you could hook your tape on it. And then you walked over here and then just pulled it out and moved this back this way a foot. Next time you measure, it's going to be 8 foot. Okay, so that's the way we get the first stake in above toe. That's a critical stake. So let's see, where did we leave off? Hold the plumb bob, pull the 8 foot distance, plumb it again. This time it should be correct. So let's assume we've got this first stake in there at 8 foot. And we haven't dealt with this 4 foot vertical yet. Let's see what's next. Well, we went through that. We went through that. Here's an illustration of what I was just saying. We got this guy set. We pulled it back. Got it set at 8 foot. And this is our 4 foot vertical. We want to go up 4 foot and over 8 foot. And that's where our grade's going to be. So let's see where we've done this, we've done that. Here's our offset level. So that hub is in place. And so all we need to do next is get this elevation of 4 feet here. In other words, we're coming up imaginary 4 feet and then 8 foot horizontal, and that's going to be the grade. So what do we do? How do we do that? Well, look here. Just walk up here and make a mark. Right there. Make a mark with a marking pen about a foot above the dirt. Somewhere up a foot above the dirt. Just make a mark. Horizontally across the narrow side, because you're looking at the narrow side. Just a tick mark. Horizontally. About, what did it say? A foot above the dirt. All right. Which should be facing you, the narrow side. To place the engineer's rule on top, right here, narrow down here. Place the engineer's rule on top of the hub. Take a shot at that mark you just put up there and see what your engineer's rule reads. If you want that mark to be 4 foot plus a 1 foot boot, so your engineer's rule is graduated in feet and tenths of a feet. So for instance, what I want to see, I need a mark that's 5 foot up. So I just went up there and I put a mark approximately where I wanted it, about a foot above the dirt. And let's say that it read, 4.8. What do I need to do? I'm shooting right at that mark and it's reading 4.8. I want it to read 5 point. I want it to read 5.0. So 4.8, if I go up here and move that mark up 2/10 and take another shot, what's it going to read? 5 foot. See, all of this is about doing this by yourself. Once again, I want to come up to get my exact grade on this first stake. I want to come up a foot higher than that hub, and I want to be out here 8 foot. Well, I'm out here 8 foot, but I don't want to be 4 foot. I want to be 4 foot, but I want a 1 foot boot, so my reading needs to be 5 foot. I just walked up here, put a mark on the narrow side of the lath, came back, got my engineer's rule out, set it down, and it read 4.8. And I needed to read 5.0. Easy fix. That mark, I just measure up 2/10. And then I come back and I should be reading 5 foot. So again, I have a 5 foot mark, a 5 foot above this toe hub right here. There's a mark. But to find grade, since I'm using a 1 foot hike up, I want to measure down a foot. And that puts me on grade. And that's where I want to be. I want to be up 4 foot and over 8 foot. And guess what the rest of them are going to be since that's up 4 feet, over 8 feet. And then we're at the top. Then we're at the top because that's the total field. The total field is a multiple of 4. So we got our first slope stake in the ground. And we do that going on up this slope as we're building it out this way in a stair-step fashion. Okay, that may take a while to sink in. Oh, here's the example. If the reading is 4.8, then your mark needs to be raised 2/10 to a correct slope grade of 5 foot above the level of the hub. 5 foot above this. It's the same thing. From this mark, measure down a foot. We talked about that. And that's where the grade is. You can either mark it with the crow foot, as in the figure 68, or drive a hub in the ground. Crow's foot are quicker. Hubs are more accurate. Most experienced grade checkers use broken or previously used laths for this purpose instead of hubs. Since a previously marked lath cannot be used over without causing confusion. You don't use a lath that's already been marked on. A 1 foot length is about right for most fill slopes without causing confusion. It has no value unless it could 1 foot to make your homemade hub. Break a lath and drive it in the ground. If you don't want to use a crow's foot, drive it until you have this, get this, go down, put your grade mark there, put a hub in the ground if you want to. Out of an old lath is what they're saying. Due to soil conditions, a job specification is frequently necessary to build a fill slope, overfilled by as much as a foot. Build it up higher than thicker, more dirt than you're going to need. Up here, the rough grade would be a foot higher than this overfill. 1 foot, overfill as much as a foot. That gives us something to cut. When you're grading, you don't want to fill unless you have to. You want to be too high. You want to always be able to cut down because you've probably already compacted it, and if you bring in more dirt, it'll need compacting. So always go high in your rough grade. So if the slope is overfilled, then obviously grade would be covered up. That's why we have a boot. Grade would be covered up, and the only visible mark would be the one you already established, the 1 foot boot, that guy. So above the slope grade. This is commonly known as a high cup, and you would so identify it as a 1 foot high cup by tying a white ribbon covering the horizontal mark. White is a 1 foot uh, uh, boot. Uh, Red is a 2 foot. So see the color codes. We'll get to those. Probably not during this session. Due to the rise and fall of natural ground, you rarely have slopes that rise a convenient 4 or 8 feet or any other round dimension. It then becomes necessary to compute dimensions other than round figures. Here we go. The ideal place to deal with these dimensions on a field slope, is when you set the first stake above toe. When you do this, this is where you want to deal with the oddball dimension, is what we're coming to. So let's see. Let me get back up. Due to rise and fall, rarely a convenient 4 or 8 feet or other round dimensions becomes necessary to compute the ideal place to deal with these dimensions on a field slope is when you set the first stake above toe. For example, if you had a field that was going to be 14 and 8/10 total field above the toe with a slope of 2 to 1, you would use the greatest multiple of 4, our vertical rise from slope stake to slope stake. That's what we're after. The greatest multiple of 4 that can be subtracted from 14.8. So what is that? In this case, it's 12. And you would deduct it from the vertical height of 14.8 for its difference of 2.8. 14.8 minus 12, which is the highest multiple of 4 that can be deducted or subtracted from 14.8, leaving a difference of 2.8 vertical rise. So to even this Suckerville out, I have to do something with that 2.8 difference. This is what I'm going to do. Where is my stake? I got 2.8. Since this slope is 2 to 1, multiply the vertical rise of 2.8 times 2, since it's a 2 to 1 slope. Multiply it times 2 to calculate a horizontal dimension of 5.6 as shown in 69. Look at all this stuff going on we've been talking about. So we have a total fill of 14.8 right here. Well, we want to get rid of the oddball here. Highest multiple of 4 that you can subtract from 14.8 is 12. 14.8 minus 12 leaves 2.8. So our first vertical for our first stake above slope has a vertical of 2.8. Now, to get this dimension, we take the vertical dimension, 2.8, multiply it times the slope ratio of 2, and that gives us a horizontal dimension of 5.6. So up here, we were 4 and 8 because we had a multiple of 4. We didn't have to get rid of excess stuff or make things work out. We got rid of all the excess. Guess what every other stake is going to be until, because it's only going to be, once you take that 2.8, how many feet are going to be left to go up? 12. So it's going to be, the rest of the way, it's going to be 4 and 8. 4 and 8. 4 and 8. 3 times. Because 3 times 4 is 12, and we'll be there. So the thing, I always look at this as the remainder from when I was in grade school learning long division. I have to get rid of this thing, and I have to make it come out 4 and whatever the ratio is. If it's 2 to 1 and then 4 foot vertical, it's going to be 8. If it's 3 to 1, 4 foot vertical, it's going to be 12. Okay, That's setting the first stake above toe in an ideal situation here and real world situation. Everything ain't gonna always work out, right? So after the first horizontal line of slope stakes has been put in place, it is a case of repeating the process every time the slope has risen an additional 42 feet until you reach the top of the slope. Now, where does the 42 feet come in? 40? The slope has risen and okay. I'm not sure what we're dealing with here. We're going to be the total fill is 14.8. That's as far as we're going to go. I don't know why we got 42 feet. None of this is going to add up to. There's your 14.8. Now it's a 2 to 1, so 14.8 times there's your 29.6. That's your horizontal distance. That's your vertical distance. Oh, when we get up to 42 feet, we got to repeat the process. I'm not getting that, fellas. Figure 70. Oh, I don't get to have a figure 70. That's figure 71. I think we have a misprint here, guys. Sorry. I don't have a figure. Here's fix 69. I don't know what they could be talking about. I really don't. But this is a way to get you a slope that you desired or requested right here. And this is that picture that shows you a slope that's in a three-dimensional format. So let's read this. Always use the greatest vertical height that is practical in staking slope. 4 feet plus a foot hike up is the greatest round feet dimension that most people can handle. In other words, we're not all 7 foot. Time is money. Using a lesser vertical height also, like 3 feet instead of 4, takes extra stakes and would take longer. The slope, maybe this is figure 70. I don't quite get it, but keep reading that most people can handle. Like 3 feet is too many. Such would be the case in staking the slope in figure 70. Don't add to your workload. Think ahead and save yourself additional work. This is figure 70, I think. Okay, as the slope takes shape, a pattern will begin to appear as illustrated in figure 71. Pattern of slope stakes on a field slope. All lined up this way, this way. It's real important. When the field slope has about, here we go, 39 or 42 yet to be filled to reach a bench grade or housing pad, sometimes it's necessary to tie one lath on top of the other with 2 pieces of ribbon so that the equipment operator can see what it's talking about. Now this I know what they're talking about. We keep building this up and we get close. See, this is how they feel right here. And they were doing this all the way up and we're grading it all they're doing. So we want to put a grade ribbon here So we got to tie two stakes together so that scraper operator, when he gets up about right here, he'll know not to bring much more dirt. That's what that's talking about. By doing this, all operators can see how much fill is still required when and know when to stop dumping at that location. This right here is pretty much self-explanatory. Uh, this is okay. Let's just see when it quits being self-explanatory. Frequently, your duties will place you elsewhere on the job at the time bench or pad grade is reached. If you had not previously provided that ribbon a grade mark at the proper elevator, the equipment operators would overfill the area before they found out that grade had already been reached. This then necessitates the review of the steps toward building a slope from the toe offset state. This removal of excess material, which is contractor does not get paid for. So here, review of the steps toward building a fill slope from the toe offset stake. So first thing, locate the offset stake. Remember what an offset stake looks like right there. And there's one right here, offset stakes. So locate it and then get the area prepared, clean out, knock down a tree if you have to. Whatever you got to do is get this offset stake in the ground. And then put in a toe lath and hubs all up and down that thing. Don't go down, down, down. Go toes or tops all the way across. Put in toe lath and hubs. After the fill has been brought up to 5 feet, establish the first stake. We did that. Eliminate any vertical dimensions other than the round. Highest multiple of 4 deal. Here they are, 16, 12, 8, and 4. Put a mark on the small edge of the lath about a foot above the ground. With the engineer's rule and hand level, establish a 1 foot hike up. That's when I said just walk up there and put a mark on it, take a shot at it. If it reads 4.8, then you need to move it 2/10. Move the mark 2/10, and it'll read 5 foot. Drive a hub to set drive a hub to grade. Set a lath and mark the grade elevation, including the one. Tie a white ribbon if it's a 1 foot hike up mark. By the way, those hike ups are called boots. The hike up is where you put the boot, and we'll get to that. Set a new stake line, 4 foot above the last stake line. So we're setting these lines right here. This is this has something to do with that 40 foot. But you set all the toe stakes first. Then you set your 5 foot up here. Remember, it said you set all of your, as you're putting this dirt down, you set your first stake above toe, and then you consider setting in this direction. And this is just showing you what a stake, what happens when you're out of line. You get a stake that's off line on the arrow. They need to be in line. And let's see, these are just steps in building it. And here's a bit of an illustration with the step. This is saying the same thing. Locate the offset stake right here, clear and grub. The toe area must be filled low. Then that's where your lost offset stake. These are just the steps, and here is the the slope stakes in between. Now let's see what's next. Are we in the tailgate? Well, I'm not going to go through that. I don't want to go through that. I bet I'm going to have to. We've already started that. That's okay. Let's go back to the module so I can show you that assignment. Now you're going to have questions, and they're not going to get answered as you're watching this video. Get a pencil and paper out. Write down what you did not understand. If we need to have a big blue button, synchronous class, we got time to do that on your time, whenever you want to. If we need to go back through what we went back through, we can do that. So let's see, what am I doing? I'm getting back to the modules so I can get back. Can I cheat? No. If I can, I don't know how. So let me get back to module 4 where we were. We went through building, we went through slope staking, we went through overview, we had the intro video. You will have tomorrow this video, and here's a quiz, but here's what I wanted to show you. I think it's this. Here's your assignment for week 4. Determine the horizontal and vertical distances for your first stake above toe using the greatest practical dimensions. That would be the multiple of 4. Use only a 4-foot vertical dimension above the first stake row. Write your answers first with the number, then the letter. Number 1, E, number 2, D, because you're going to put stuff in here. Where'd they go? 4-foot vertical. Write your answers first with the number, then the letter. You'll have a text box. And finally, followed by your answer. Use decimals. Don't forget to start from the bottom. So let's look at this first one. The first thing you're going to have to do is, this is your toe stake right here. It says fill 23/4 at 1.5 to 1. Well, we want the rest of these to be 4 and 4. So what is the highest multiple that can be subtracted of 4 that can be subtracted from 23.4? Well, that'd be, what is that? 12. Am I correct? 16. That's correct. So 23.4 to 3.4 minus 16 equals, that didn't work out. Is that the highest? No, 20. 20, sorry about that. 20 is the high. So 23.4 minus 20 leaves 3.4. Your first vertical for your first stake is what? 3.4. Because 23.4 minus 20 equals 3.4. What is your ratio? We know the vertical is 3.4. 3.4 times the ratio is 1.5. That equals 5.1. There it is. So you get a give me on your first one, right? So if this is 3.4, this is 5.1, what is this next one going to be? What are you going to write right here? You're already here, so you've got 3.4 taken care of. So this right here is 4 foot. So what's left? Fill from here. From here, what's left? It's all going to be 4s, right? Fill from here will be fill, excuse me, 1, 2, 3, 4. Fill 16 at 1.5 to 1. What's this one going to be? Fill 12, right? We got rid of another 4 feet. Fill 8, fill 4. Make sense? First thing you do is calculate these. Down here, you got 7.6. Look at this. So what's the highest multiple of 4 that can be subtracted from 7.6? Well, that would be 3.6. So you would need to put down 3.6 times 2. Your horizontal would be 7. Your horizontal would be set from here to here would be 7.2. But how far would it be from here to the top? 4 foot. Because you got rid of that. Highest multiple of 4 is 4, and that leaves 3.6. So the 3.6 went right here. So this would be 4. Down here, 22.4. What is the highest multiple of 4 that can be subtracted from 22.4? 20. That leaves 2.4, right? So you take off 2.4 from 20. These will all be 4, 8, 12. What's that? 16. Wait, let me see. 4. No. This will be 4. And then, I'm sorry, this will be 16, 12. I can't subtract. This is going to be 20 now. It's not going to be 22. It's going to be 20. So from here, you're going to have 4, 4, 4, 4, 4. So this would be fill 20. This would be fill 16. This would be fill 12. This would be fill 8. This would be fill 4. That's all you got to worry about, really, is knowing to get rid of this, and just everything else is going to be 4. Here's 15/8. Highest multiple right there, 12. That leaves 3.8. So right here it's going to be 4, 4, 4. So it's going to be fill 12, fill 8, fill 4. Write that in each one of those. Now, and that's all you got to do for that. I gave you the answers. These are all 4 foot. You just start with the most. You got 1, 2, 3, 4, 5. That's 20 feet. So this would be fill 20, fill 16, fill 12, fill 8, fill 4. And you do that in your text box. Just put down number 1, E. What are you going to put? Fill whatever. A, fill 4, 2, 3, fill 12, fill 8, etc., etc. That would just be typed in your text box. Okay, I want to show you that. Your multiple choice, you can go back to the video. Let me make sure I don't have a next. I don't want to do the quizzes. You guys can do those. No. So that's going to stop the video. Let me go to the modules, take one final look. Yeah, we did it. Don't forget to do the tailgate. You have, oh, I'm going to get on the right one. Week 4. Don't forget to do the tailgate, culture and construction. We just went through the assignment. You'll have a week 4 quiz 5, and that'll be a multiple choice, and it'll have questions about what we just did. It'll have a ton of questions about, you have a total fill of 14.8. What is your vertical for the first state? So highest multiple of 4 that can be subtracted from blah, blah, blah. There'll be a bunch of those. So if you get a snag, give me a call, and we'll see if we can get it worked out on the phone. And I guess that'll be the end of that. You guys have a good night, day, or morning.